Hey, good afternoon, everyone.
Good evening, Professor.
Good evening, Malaysia. All right. Okay. Adjust the volume on my other computer. Okay. All right. Uh, so today, today is Wednesday, August 16th, and after today, we have only 3 days left. Right? We have only 3 days left. Thursday and next Monday and Tuesday. So we're really, um, towards the end of the summer semester, summer term, right? Summer immersion. So we have only two things left, right? I mean, as far as the tests are concerned, you have quiz two, which started yesterday and due this Friday, and which started today actually, and due this Friday. And after that, the final will start on Sunday uh, and on Tuesday, because Tuesday is the last day of class. Okay. Um, yeah. Good afternoon, Rostam. Good afternoon. So uh, let's pick it up from where we uh, paused yesterday. Um, we were just going over what discounted cash flow model is uh, about and how it is derived. Basically, the concept of um, the infinite series, right? This is called infinite geometric series, right? Because it's increasing geometrically. The denominator is increasing geometrically, and since stock doesn't end, right? Stock goes on forever. At infinite time, at infinite future point in time, right? At some infinite future point in. So obviously, infinite future doesn't have any particular point. But if we, for the sake of argument, right? If we can pick an infinite point, at that point, the future value of the stock, there will be some finite amount, finite number, right? Finite quantity. On the other hand, the denominator, which is slightly greater than 1 raised to infinity, will be an infinitely large number. So obviously, a finite number divided by infinitely large number, it will be close to 0. Just meaningless. So it drops out. And you might wonder also, the dividend at infinite future, wouldn't that be irrelevant? Because by the same analogy, it's going to have to drop. Yes, it will be irrelevant. But we're going to just keep it, uh, uh, we're going to just keep it just for the, just to express it as an infinite series. Okay. So from, let's pick it up from very, very small number, right? So that means if this term is going to drop out because it's meaningless, it's going to be something close to 0, it's almost to 0, so we don't have to consider this, right? Of course, then you might wonder, isn't this going to be also isn't this going to drop out? Yes, because it's going to drop out, but because any number divided by infinitely large number, but then it keeps on going. It's going infinitely, right? Keeps on going. So just to represent that this number keeps on going, right? We'll have to leave it like that. Okay, but this one drops out. Then what do you see? All you see is just the present values of all these dividends. All right? All you see is the present value of all these dividends. So that's why it's called DDM, dividend discount model, right? It's called DDM for that reason. Now, because you're only, all cash flow is dividend. Okay, so let me erase this and okay. So then our next question is, okay, so how does that, I told you that, in stock valuation, there are 4 models. So how does that fork into 4 models? How does that, develop into 4 models? First, let's take a look at the first model. Remember, the first model is called constant dividend model. Constant dividend model. And in constant dividend model, let me use S0 for, or S for price of the stock. In other words, intrinsic value of the stock or rational price of the stock. And in constant dividend model, it means dividend is always the same, right? Dividend at time 1, time 2, time 3, time 4, there's no difference. So we don't need time subscript because they are all the same, right? At any period, they're all the same. So it will be simply like, all the dividends are the same, discounted once. And it keeps on going like this. Let's call, and then there will be dividend 1 plus R raised to n minus infinity minus 1, because it keeps on going. And there's going to be the same dividend because it's paying constant dividend, right? Growth rate is 0, right? Zero growth, constant dividend, and then it goes to infinity, okay? Let's call this equation 1. I don't have space to write it. Let's call this equation 1. So this is basically the model of a constant dividend. Now, let me multiply 1 plus R to equation 1. If I multiply it by 1 plus R, so if you multiply 1 plus R, that means you'll have to multiply that to every to both left-hand side and the right-hand side, right? So if I multiply it by n plus and I'm going to call this equation 2, right? Equation 2. If you multiply equation 1 by 1 plus R, the equation 2 will be 1 plus R, and the left-hand side, 1 plus R times S 0. And on the right-hand side, everything will, this one will become what? It will become this times 1 plus R. So it will become just D, isn't that right? Because 1 plus R and 1 plus R, they cancel out. And this one becomes D over 1 plus R, right? And it keeps on going. And this one will become d over 1 plus r right raised to infinity minus 2. This one becomes infinity minus 2. And then this one becomes infinity 1 plus r raised to infinity minus 1. But because it's infinity, it's inevitable. There will still be, infinity means, infinity minus 1 doesn't make it stop. I mean, it's going to keep going. So we'll have something here, right? D over still infinity, right? Because that's the definition of infinity. Keeps going. So let's think about it. What should I do? If I subtract 1 from 2, equation 1 from equation 2, what's it going to become? Because equation 1 is being subtracted, all the signs here, right, are negative, right? Think about it. In other words, these two will cancel out because it's negative, right? It's subtracted, and there will be, the d over 1 plus r squared gets, so they cancel out, and there will be d over 1 plus r raised to infinity minus 2, so it will be, canceled out, and these two will be canceled out. These two will cancel out, right? So then, finally, what do you have? Eventually, what you will be left with 1 plus r times S0 minus S0 in the left-hand side. And on the right-hand side, just dividend, right? See? 1 plus r s squared, s, right? Minus s. So then, if I open this parenthesis and rearrange it, right, it's going to be what? S0 plus r S0 minus S0. Okay, and on the right-hand side, dividend. And what's it going to be? These two will cancel out. So you're left with r S0 equals d. So left with rs. Right? Then what are we solving for? We're solving for S0, right? Right? And it's x times y equals z structure, right? So solving for S0, dividend over r, right? Hence the formula. You might have noticed, as you were looking at the slide, you might have noticed, oh, that was so simple. How could it be? I mean, that's so, well, the result is very simple. The outcome of that formula is that model is very simple, but the process isn't that simple. But, that's why it reduces to d over r, right? And it's called, perpetuity. Also, perpetuity means what? Remember, perpetuity is like annuity, but it's annuity going forever. Perpetual annuity. Consider that as perpetual annuity. Perpetuity, perpetuity by itself means, eternal, eternity, right? Meaning, but this is constant amount, right? Like annuity, going forever with no end point. Hence, perpetual annuity, perpetuity, right? Perpetuity. Now and so zero growth model is perpetuity, actually, right? Zero growth model, or constant dividend model is perpetuity, right? And this is how you do that. But then let me go back to the slide, and let me go back to the slide. So if you think about it, the perpetuity is what would fit? What would be the case of perpetuity? Remember, preferred stock. What do you remember about the preferred stock? First of all, preferred stock pays constant dividend, right? Constant dividend. That means, regardless of what the stock price may be, the dividend doesn't depend on the company's performance, right? It doesn't depend on the earnings, doesn't depend on the, therefore, with the earnings, the price would also reflect the earnings power, right? But has nothing to do with the, it doesn't change with the price level, just pays constant dividend, right? So the preferred stock fits this model exactly, right? Even if it is a common stock, if it pays, non-growing dividend, right? You value it as perpetuity, right? Okay, so and our next model, so we're not going to do the example right now because it's quite straightforward. Now, constant growth model, which means which is also called constant dividend growth model. I explained, they are quite different, because in case of constant growth model, it means dividends is growing at a constant rate. But there is another name for that. Another name is golden growth model, and the model looks this way. And I will explain to you later why the model looks this way. But why does it look? Why is it called golden growth model? Okay, let me because it was developed by an economist, a professor named Gordon. And I believe there are two famous Gordons in the in economics. But there's Robert Gordon and Robert Gordon is, I think, still alive, and it's not that Gordon. It's so different. Someone else. Who developed this model in 1950s, and but I forgot his first name. But anyway, why is it? What does the Gordon model look like? Let me also. Why is it like this? Basically, if you look at it, it's like dividend at time t+1 over r. R is the required return, right? Which is the discount rate, minus G. G is the growth rate, right? Growth rate of dividend. Of course, growth rate of dividend is also the growth rate of the earnings. Now, but why? How come it looks this way? I'll explain, because it may not look You may not have any question about it. I mean, why is it shaped this way? Why does it look like this way? Probably you might want, um, why do we subtract growth rate from the R? I mean, uh, as a in my early graduate school years, as a new graduate student, I try to wrap my head around this problem. Eventually, I figured it out, but uh, it looks like I was just thinking, trying to justify or rationalize this, and thinking that because uh, the growth rate is because of uh, probably we might have to subtract the effect of the growth from the return because that is an extra gain or something. I mean, I was trying to understand why it is R minus G. Huh? All those, all those thinkings without math, I mean, exact math to justify, uh, it is nothing but just a freewheeling thoughts. And in math, in economics, finance, math, or science, freewheeling thoughts are not allowed. It's a, it's like a pariah, you know. Uh, I'm sorry to say, but for anybody who is doing science based on math, for them, literature is not a science. Literature is because it's all free-willing thoughts, right? Anything without mathematical uh, underpinning, without any mathematical um, proof or mathematical justification, uh, it is nothing but a spoof, a puffy thing, right? Fuzzy, puffy, right? Um, and those, so it's a pariah, right? Um, just children's play, right? Because any child can do free-willing thought. Only a grown-up, or not just any grown-up, only a very intelligent person can give anything a concrete structure that can not be defeated by any argument, right? And it's based on math. It comes from math. Defending that structure, right, by some jabbings or dabbling arguments, right? Uh, a solid structure is built on the math, right? So that's how important the math is. That's why you know I'm I've been doing think about it. That's why if you want to do finance, economics, you have to be you have to have a solid foundation in math. Okay. Uh, so let me. So I eventually, as a grad student, I eventually figured out why the formula turns this way. First of all, dividend at time t plus one, of course, is future cash flow. But if how do we know what it's going to be? I mean, past dividends we know, and the most recent dividend at time t is the most recent dividend, right? It's time zero, so we know we have it, right? We have the data. So actually, to express it this way, it should be S stock price at time t, right? Uh, But how do we know what dividend at time t+1 will be? Well, if we know the growth rate of the dividend growth rate, all we need to do is the most recent dividend, right? Dividend at time t times 1 plus g. Do the compounding, right? This is just one period compounding, right? So we can forecast dividend at time t+1. And then it's discounting to present, right? But then why isn't that 1 plus r minus g, or, why is it? So I'm going to, it may take a little more time, but I'm going to explain that to you. And we're going to, from next class, we're going to do, just the examples. Now, so let me switch to another file. And somehow I put it in a different file. Oh, I put it in a return on risk. So let me bring it up. Oh. Okay, here it is. Alrighty, so do you guys see this? Okay. See this? So Gordon growth model, AKA, right, Gordon growth model, or, constant growth model is, and this is my derivation, my interpretation. Actually, Professor Gordon, when he developed this model back in 1950 something, right? He may have proceeded in a different way, or later the other versions of this, other interpretation of this model may take different route, but this is how I got to that result. Okay, first of all, this is one period compounding. I mean, if you buy the stock today at today's price, you'll have to pay today's price, right? Which is price at time t, and it will grow. I mean, this is not just the growth rate. This is return. K stands for cost of capital, which is return. And remember, the return and the growth are slightly different. Why? You remember I used, at the beginning, house value model, right? House value example. And there were two scenarios, scenario 1 and scenario 2. Scenario 1, there's only capital gains. You buy the house, but you use it as just your residence. So there's no cash flow, rental income, right? In other words, there's only one type of cash flow, which is, capital gains. 10 years later, you sell the house, there's capital gains, if the house value increased. But only one type of cash flow there. But in scenario 2, you buy the house and rent it out. You buy it for that purpose, rental property. In that case, there are two types of cash flow. One, capital gains. 10 years later, the value of the property increased, so there's capital gains. Second, the rental income, right? And as we discussed the annualized return, holding period and annual return, I told you, in scenario 1, the house value grew right? From time 0 to time 10 or time 15. Uh, so um, basically the return is the same thing as the growth rate, right? But in scenario 2, return and growth rates are different because growth rate refers to the capital gains portion, right? Capital gains, right? Because the um, how there that's the growth in the house value, so capital gains. But return includes not only the capital gains, but all those cash flows, the rental income, right? So when you take the when you calculate the return in the scenario 2, then uh, growth rate and returns would slightly differ, right? It will be different. And that's the same reason. Well, uh, if you have nothing but in the next period, time t plus 1, if you have nothing but uh, pt plus 1, the price in the next period, then this is simply a growth rate, not return. But in the next period, if you have price at time t plus 1, not only that, but also dividend at time t plus 1, then that's the return, right? This K represents return. I told you, talked about that. K stands for cost of capital. Now, at the beginning, when we did ROI, I told you cost of capital uh, uh, breaks down into a cost of equity and cost of debt, right? Cost of equity is the return, right? Return on the stock. So this is one period, growth model of the stock, right? But then if I want to isolate only 1 plus k, right? What do I need to do? I will have to divide both sides by pt. So if I do that, I will get this on the right-hand side. And then on the left-hand side, I will have this, pt plus 1, right? But then what is pt plus 1? Isn't pt plus 1 pt times 1 plus growth rate? In other words, isn't that, growth rate meaning, isn't that the capital, isn't that the growth rate of the capital, initial capital, right? PT grew to PT plus 1 by as much as the growth rate. In other words, the house value alone, right, over 10 years, grew from, grew by, 10% every year, right? Then over 10 years, it's going to be 1.1 raised to 10. And the house value alone, the capital gains portion will be, right? Uh, in other words, house value at time 10, P10, P sub 10 will be P sub 0 times 1.1 raised to 10, right? So this is one period, so it's 1 plus G raised to 1, right? So you get that. Then we can, distribute this, right? And then it's going to be PT, in other words, PT, right? Plus PT times G, right? Right? Plus, so if you multiply this, it's going to be PT and PTG, PT times G, right? And PT and PT will cancel out. So it becomes 1. PT and PT will cancel out, becomes 1. PT times G over PT, PT and PT will cancel out, just becomes G. This cannot cancel because it's dt plus 1 over pt. So it's like this. Now let's rearrange the terms. Move this to the right-hand side, then 1 and the signs will change, algebraic signs will change. If you move this to the right-hand side, it will be minus, minus, right? Negative. So 1 and 1 will cancel out, right? And it's going to be 1 and 1 will cancel out, and it's going to be k minus g in the right-hand side. and in the left-hand side, dt plus 1. So if you solve this for pt, what does it become? You divide this by this. So it's going to be dt plus 1 over k minus g, and then that's k is what? R, the required return. So hence we arrive at this outcome, right? Arrive at this conclusion. Okay, this is my own derivation of golden growth model, and I discovered it, right? This is how I understood the golden growth model, how it became this, right? And I discovered it when I was, as a grad student. That was like 30 years ago. It was like,
Right.
yeah.
Oh, right. That wraps up illustration of how golden growth model is derived. I don't know why my video is so slow. I mean, usually I played at 1.5 speed. Somehow, something just like in the old days when we used the cassette tape. You probably don't remember cassette tape, but when I was in my 20s and it was cassette tape. And when you play it over and over, then the tape gets elongated, or the tape gets, so then when you played it, it sounds very slow. But anyway, so that was video number 3. So we're going to move on to number 4, right? Video number 4. Where's my time? And it's cut up actually, into part A and part 4A and part 4B. So let's take this to part 4A. So we're going to move on to the next model, or probably, before we move on to the next model, I'm going to be showing you some example of golden growth model. Okay? So let's take this.
Well, stock valuation models. Now, in our last video, we discussed, or we rather looked into the background of the golden growth model. In other words, how the model, why the question was, why does the model look like this? Why is it, R minus G in the denominator, and how did it come about, and where did it come from, right? I mean, it's easy to understand that because it's dividend discount model, right? We're dividing it by dividend at time t plus 1. I mean, that makes sense, and it's basically what's in question, what's to your interest is actually how much dividend is this stock going to pay. So it's the future dividend that's interesting to you, and more specifically and more immediately is the immediate future dividend, right? So okay, dividend at time t plus 1, and one sure way, or one very rational way and logical way to forecast that dividend at time t plus 1 is by compounding it by growth rate of the dividend, right? And the growth rate here we are talking about is the constant growth rate. And again, of course, in reality, you all understand from the day one, I mean, from our first topic, you've learned that, and you've seen the examples, that the dividends or any cash flow from investment cannot be constant unless it is like, bond or rent payment from, renting out or subletting a property. But the dividend income, the cash flow from dividends from the stocks, like the dividends, right? They are incidental income. In other words, the nature of this cash flow is incidental to the profit right? Or it's dependent on the profit. In other words, profit changes constantly, right? There's no guarantee that last quarter's profit, if the company had wonderful last quarter profit, there's no guarantee that it will continue in the current quarter or in the next quarter, right? So, and there's no guarantee it's going to continue at the same rate, right? So it's quite natural that the dividends do not grow in reality at a constant rate. It's uneven. It's supposed to be uneven, and that's only natural, right? It's only natural. It's uneven. But then we would have to find, although the actual growth rates are uneven, we need to find a constant growth rate. What does that mean? Well, we know how to, right? From the first topic, from the day one, this is what you learned. You must annualize it, right? Annualize, or it can be semi-annualize or quarterize or whatever. But all that means is taking the geometric average, right? Of all of those uneven growth rates. Well, we know. And also, the next question is, why the denominator looks like this, and that's what we talked about in our last video. Basically, the steps of derivation, and through the process of the derivation, right? Through derivation, we arrived at this result. Of course, sometimes that R is also called K, cost of capital, right? In this case, cost of equity, right? Because cost of equity. Please bear with me, because this is so difficult to write with it's not writing, it's drawing with a mouse, right? So it's so difficult. So now let's take a look at the next example, and we need to do the example of the we didn't do the example of even the constant dividend model or perpetuity model. But it's really easy. So here's the example. Chuck Swimmer estimates that the dividend of Denim Company, an established textile producer, is expected to remain constant at $3 per share indefinitely. So if his required return, in other words, that's R or K, right? Cost of equity. Which is also required return, right? Is 15%, right? And what do you do? Because the dividend is constant, right? It says expected to remain constant, right? $3, right? Divided by required return 0.15. So you come to $20, right? Okay. Now, and I probably have mentioned that usually the notation for stock price is I use S here for S at time 0, right? Time 0 being the present. But also most common notation is V, value, meaning value, right? So V sub 0, right? Value at time 0, right? That's another notation. So this is something you need to know as well. Now here in this publisher supplied material, right? I mean, graphics, they used P0, meaning price, but since we are talking about stock specifically, right? P0, and they just simply truncated the entire process and just skipping all the steps of derivation. They come to remember in constant dividend model, I showed you the process called infinite geometric series, right? Which is was fully illustrated and demonstrated in the previous video, right? And then, but they all truncated it, and without intervening steps. In other words, they involve as little math as possible, because, of course, if they write a material, right, educational material that is very thorough and detailed in math, it's not very approachable to the general audience. And if it is not approachable to general audience, they are, what does that mean? They cannot sell, right? So the books are generally, all these books are generally made with certain target market, right? Of course, the most advanced the books on the most advanced level, on graduate level, on doctoral level, the books that they use on doctoral level. Think about it. They're not writing it. They're not writing such a book to sell, right? A huge marketing campaign, or that's not their concern, because obviously they know it has a very limited audience, right? Writing a book on a very advanced level is a matter of prestige, and a matter of pride and prestige, right? And privilege. You're not writing a textbook for doctoral audience to make money, right? To make money, you would write a very, very easy book like finance for dummies, investment for dummies. It will sell, because it can speak to a huge audience, literally even to dummies, right? It will be, the target market is so huge, right? And if you are bent on, I mean, if you're intent on making money, you would write a book like that. And also for the writership, right? For the authorship, right? Also, the market for authorship is also free for all. It's almost like, because you don't have to be a PhD in, economics or finance, right? You just have some working knowledge of, working knowledge of, stock market, and you can write a book. I mean, you worked for, probably, for Goldman Sachs. You just have to work for Goldman Sachs, you must have, you can have bachelor's only and still work for Goldman Sachs, but you would be mostly in the sales job, marketing job, right? But for any investment bank or for any asset management firms, and to have, they also have sales jobs, because they have to bring in the client's money, right? Usually, so for doing client relations, there are people who don't need professional education or expert training. They just need to be a good they need to be a presentable people. Just need to be presentable people, like well groomed, just look decent and sophisticated. I mean, speaks not just proficiently, but speak sophisticated way. Words are escaping me. Usually there's I mean, you have to be. That's what depending on what you're selling. If you're selling like a private jet, or a private yacht, a fancy private yacht, or fancy supercars, super like British custom ordered cars, like McLaren, or for Bugatti, or all these upscale cars, right? That are at least like above $200,000-$300,000, right? You have to, you don't have to have much, you don't need much education. I mean, you just need to be decent and look, you need to look very sleek, right? I know people like that. They are in an high profile or upscale in the sales profession, sales jobs that are dealing with upscale and high profile clients, and they are dressed like they are dressed like corporate executives, or very power dressed, but they're just in sales. Of course they make a lot of money, right? But look very sleek. They get they go to for their manicures and pedicures, and even skincare service, because how they look affects a lot how much they sell. There's performance record depends on, but literally what I'm saying is if you're working for, you can still work for Goldman Sachs or investment banks, without a master's degree or a graduate degree, right? Bachelor's degree would be enough. Sometimes I've seen in the past, there were some people in Goldman who worked for Goldman Sachs. I don't know if they were on permanent basis or just, but nothing more than high school diploma. But they look and talk right? They look and talk right to the target audience. But anyway, to have a secure job in high finance, right? Of course, you have to have at least graduate degree, right? But again, what I'm talking about is the books are written with certain target market in mind. You understand? And if the book is advanced, right? If the material is advanced, of course you will have very limited audience, and you don't, you can't sell a lot, right? But as long as there's a steady, I mean, there will be graduate schools, at least for the next 50 years. There will be people will be pursuing master's degree and beyond, even above doctorate, right? PhD. There are people who are pursuing advanced degrees for their own promotion, right? In other words, not only accomplishment, it's not self-accomplishment, self-achievement, right? But actually, not only that, PhD in economics or finance or math or statistics or engineering, science, they are related to also related to income, related to job security, related to prestige, right? So there will be constant, although small audience every year, but there will be continuous demand for advanced level material. But if you are, and some people who don't even have a graduate degree, with some experience in the financial market, financial industry, they can still write books, like something for dummies. And somewhere along in the topic of rule of 72, I explained to you why there are so many YouTube videos about rule of 72, but really none of only a few of them, handful of them, really explain how it came about, and it's about how and why, right? And the videos about just what is rule of 72, and but it doesn't. But the videos that doesn't explain why of all the numbers, why of all the divisors, why of all the dividends, why 72? I mean, where did that come from? I mean, the videos that don't address that aspect, why and where it come from, right? Those are rubbish, right? And those are basically like rule of 72 for dummies, right? And that, on the surface, right, it may seem like those are very useful practical videos, but then think about it. Using rule of 72 without understanding why of all the numbers 72 and where it came about, where it come from, and why and how it came about, right? This is what is more important than what is rule of 72. You understand? So just like that, there may be many videos, many educational, so-called open resource, educational resource materials, but if they are not really academically meaningful, they are and if they are more like something for dummies, they are generally rubbish. Okay, so anyway, I'm sorry to digress or too much. I had to mention that because this model is skipping that skipping that step, right? Skipping all that. So let's go to again this also skips why golden growth model came to become like this, how it came to look like this, right? Steps of all those steps of derivations, simply ignoring, right? So that's why I don't like about because this material was made for like very low level audience. I mean, just like really intro level, right? But you understand, my lecture is not really intro level. It's just only the course number is 100, but this is at least 300 or 3,000, depending on some schools use 100 for course core. They use 100 digits, 100 hundreds, digits of hundreds. Some schools use thousands, but this is at least 300 or 3,000 level. Okay. Now, so here's the example of golden growth model. Lamar Company, a small cosmetics company, pay the following per share dividends. So Lamar's required return is 50%. So they gave us the data, right? What is it? Where is it playing? I just don't know. It's coming out of nowhere. It's coming out of nowhere. I don't know where it is coming from. I don't know why. You know, this is coming from. This is, my own other video was playing on YouTube. You know, automatically. I'm sorry about that. Okay. Somehow something triggered YouTube. So. So in this example, right, so time zero, this is time zero, right, current year, 2012 is time zero, right? So we are at the end of 2012, and this we just got paid, you know, the dividend of $1.40. And for the last 5 years, so this is time t minus 1, 2011 is time t minus 1, right? And now you can see, you can tell that this is t minus 2, t minus 3, t minus 4, this is time t minus 5, right? Makes sense? So over the last, you know, 5 years, they paid dividends. And in 2007, the dividend was $1. 2008, $1.05, and you can tell the growth rate in dividend is 5%. And then between 2008 and 2009, it is like 6.67%. It's hard. Please bear with me. It's really hard to draw with the mouse, as if, you know. And as you can see, I mean, we don't have to keep doing this over and over. The growth rate in each individual year, you will see they are all uneven, right? But then when the growth rates are uneven, you know, you might also, how do we apply, you know, golden growth model? And look, we cannot wait for the golden growth model to automatically present itself to you. I mean, we cannot wait or expect for the right situation or right problem conditions for golden growth model to present itself to us, right? Makes sense? In other words, reality, golden growth model must be applied to the reality, and the reality is dividends are growing at an uneven rate, right? But then it is when the growth rates are uneven, all we need to do is annualize it, or, you know, quarterize it, or semi-annualize it. In other words, we will need to take the geometric, right? Geometry. I'm not going to write anymore, but you understand geometric average, right? And do you remember how do you do the geometric average? Yeah, this is we did this in, you know, this is basically solving the single cash flow model for R, right? Remember? So it's future value over present value raised to 1 over n. Now the in this case, the future value is the dividend in 2012, right? So this is, you know, future value over present value raised to 1 over n minus 1. Okay, so we plug in the number, right? And we know we don't even have to. It's 1.4 over 1, so it's automatically 1.4, right? And it's 5 years, right? Then what do you get? Then you will get something like, you know, 6.9 something. Let me run the number, right? It will be almost like 6.9% or something like that. It's close to so 1.4. You can all do that with me. Raised to 1 over 5 minus 6.96, right? 6.96%, which is almost, you know, 7%. Oh, come on. All right. So then, you know, V0 stop price then $1.50, which how do we know it is $1.50? Which is, you know, what? How did you get to $1.50? $1.40 because $1.40 is dividend at time t, so multiplied by 1.0696 or 1.07, you will get $1.50, right? So that will be that's dividend at time t plus 1, right? Right, dividend at time t plus 1, and R minus or cost of equity, my growth rate, and there you go. It comes to 1875. Okay, all righty. So that's it for this segment of the lecture, and I will see you in the next video. Stop recording.
All righty. So that was the example of golden growth model, right? So let's go to the next one. And before we get started on this video, I guess it's a little early, but because the video, the next video will be another 40 minutes, right? So I think it's better to take a break at this point. It's
Yeah.
7:04. Yeah, yeah. So okay, let's take a 10-minute break and reconvene at like 7:15. Okay. All righty. So let's take a 10-minute break.
Thank you.
All righty. See ya. All right, we're back. We're back. So let's continue with our next video. Okay, let's take a listen.
Hello, video number 4, part B. Now, so in our last lecture, we discussed the golden growth model, which is also called constant growth model or constant dividend growth model. Now, so we are moving on to the variable growth model today in this lecture. Actually, if you think about it, the assumption of constant dividend growth is rather a very restrictive assumption, rather artificial assumption. As you may understand from our discussions, in our previous discussions, right, the actual growth rates are actually uneven, right? And we are just, annualizing or taking the geometric average of the growth rates to even out the uneven data, uneven actual growths. So, and even if it is uneven growth, if we are taking the average, right, the geometric average of those uneven growth rates, it's basically based on the assumption that in the long run, right, the overall growth would be on a constant basis, right? Yeah. In other words, what it is saying is, basically like this: the temporarily, right? This is something you would see in real data, especially in the stock market. I'm not talking about the price. I'm talking about the returns. Now think about it. Daily, right? You would see a lot of fluctuations, right? You would see a lot of fluctuations, ups and downs, spike and dip, right? But if this is daily or even, hourly data, although it looks like, it's chaotic, right? Like a Brownian motion, right? Brownian motion is also called random walk because it's random pattern, right? But if you're looking at, just daily data, it looks like crazy like that. But if you elevate yourself to a higher plane or higher level and look at it from more macro perspective, right? If you look at the monthly data is like, average of 30 daily data like this, right? And then from annual perspective, right? I mean, from monthly perspective, if you are averaging out, right? If you're averaging out 30 daily results, returns, it would be, on average would be, something like a flat line. I mean, because it's an average number, it would be some, median value of this. And if you compile 12 monthly averages, then and look at it from annual perspective, right? If you connect those 12 monthly averages, they would seem more like a curvilinear or more, smoothed out pattern. The pattern will look more smoothed out. Make sense? Okay. So the point is, although the actual monthly returns would be, or daily returns data, right? They seem, so hectic and chaotic. But if you can smooth it out, and from a higher macro perspective, they will always fluctuate between. I mean, 1 month it may be, 15%. Another month it will be, it may be, negative 5%. Another month it may be 10%, and so. But they are pretty much, from if you look at it from annual perspective, right? They are pretty much fluctuating within a constant range, right? So that is why we have that constant growth model or golden growth model. As I've been telling you, the actual data, maybe actual returns data, are bound to be uneven, and that's the reality. That's natural. But then from a higher macro perspective, you can see why we can why we are comfortable with using constant growth model, and that's basically based on the assumption, right, that the company is growing at some steady rate. In other words, on average, so a steady, constant rate. Excuse me. Now, but again, and think about it. Growth at a constant rate comes only at a phase when the company is relatively growing at a constant. In other words, only when the company has obtained a certain, steady phase. As we can all see from actual examples or data, companies are at the most, when the companies are first born, right, at its birth phase, right, early life of the company, it would go through a lot of fluctuations, right? The first 2 years, 2 to 3 years for most small businesses, first 2 years are critical period, 2 to 3 years. Why? Because small businesses generally either fail or take off, right? And that threshold is somewhere around 2 to 3 years. And once they pass through that point and reach some viable, steady sale and steady growth, then this company is now viable. This business is more viable. But before passing through that threshold, crossing over that threshold, the first 2 to 3 years are really, really critical time period. And I said, the first 2 to 3 years, and this is mainly for small businesses. I mean, if it is a large company, it may this threshold may be the first 5 years. But those are like critical periods. When Facebook first went public, the first 3 to 5 years was period of first 3 to 5 years was very critical period, and there was a lot of risk, right? So that brings us to the concept of product life cycle. Now, the extension of this model, I mean, it's product life cycle, but that means the product life cycle means literally products have life cycle, like birth, and growth, maturity, and demise, right? But it's a very well established and well-known theory, and then actually it's so you might wonder, some products may have life cycle, but what about the companies? I mean, stock value is derived from the company's overall performance, not just one single product. Yeah, I mean, true. So the extension of product life cycle model is actually industry life cycle. Industry life cycle. So, but it's easier to use product life cycle products as a example because they have more immediate bearings with the examples in actual life. So, now let's think about it. What product life cycle means that products are all born, right, through research and development, R&D, right? An innovative product is born as a result of R&D, right? And when I say innovative product, that means a product that has never existed before, right? So this green curve represents the innovating firm. Innovating firm means the innovator. It means simply the company that came up with an innovative product, right? Innovating firm sounds like this firm is going through innovation every day. Sounds like it is a going through a metamorphosis every day. No, it simply means a company. Metamorphosis, right? It simply means a company that just puts out an innovative product. And what's an innovative product? Innovative product simply means a novel product, not a novelty, but something that is new, original, and that has never existed before, right? So, for example, before iPhone, right, there was no smartphone. So some people may say, iPhone was not the first smartphone. There was, another company that, there may be another company that had the technology But as far as the in terms of commercial success is concerned, right? As far as the commercial success is concerned, iPhone is the first one of its kind, right? Of course, we had mobile phones before that. Mobile phones date as far back as early 1980s, 83, 84, 85, if I remember correctly. And in those days, they had a cell phone the size of a brick. It was called brick phone. It looked more like military radio, size of the military radio, and it didn't last. The battery didn't last that long, probably 30 minutes. So it was more like a status symbol. It was not. It was not actually like a useful product that you use, for its utility, but more for the status symbol. Now, anyway, so and then when it became more popularized, that was only in mid 90s, and BlackBerry and all these cell phones came out. Of course, Samsung, what they call 2G phones now, right? The flip phone and 2G, second generation phones. These days, still, they use some people use 2G phones, especially senior citizens who don't have very good acute vision. They need large keypad, no screen, no touch screen. But anyway, but iPhone was the first of its kind, and I think the iPhone 1 first came out in like 2007, and then it revolutionized the entire mobile communications industry, or IT industry in general. Yeah, but so it was an innovative product because nothing was like that. No touch screen before that, and they started to call it smartphone. But whatever they call it, that's not the point. The point is, iPhone is a result of, it's an outcome of very heavy R&D. A lot of investment went into the R&D, and then it came out, and that's stage one. And in stage one, only a handful of people use it. They're called early adopters. They and then and at that point it must have been very expensive at that point, but it was an innovative product. As soon as it hit the market, the sales, in other words, adoption by the market, right? Market is catching on, right? And then so it grew exponentially. It grew drastically, exponentially. They like to use the expression exponential growth. Exponential. What does exponential growth mean? Huh? Now, here I'm going to get to that later, but pay attention to the shape of this curve. See, the shape of this curve is not like this red curve. Red curve is growing. It's increasing at a very steady rate. Right? Steady rate up to a certain point, and steep. The steep phase, right? And then the slope of this red curve is getting flatter, right? As time goes on. But if you look at this green curve, it was starting. The growth rate seems rather relatively flatter than this range, and then as it entered this range, it gets very steeper than this range, right? So in other words, it looks like this, right? It looks like this rather than like this, right? So that's that's exponential growth, right? You might wonder, exponential. I cannot, right? It takes so much time. You might wonder. This has a steep growth pattern. It shows, the slope of this curve is steep from the beginning. Doesn't that mean this is growing at a faster rate? No, not necessarily. I mean, yeah. I mean, if you're looking at only this range, this is relatively, slow. The growth rate is, flatter. It's not what is, meant by exponential. And I'm going to get to that later. But let's take a look at this. So the innovative firm is enjoying a period of monopoly. That means, before the competitors comes into the market, they are enjoying the monopoly until that point because they are the only one. And when the innovative product is, gaining so much popularity, then the competitors enter the market. Okay, of course, the reason they are this company is the let's call this Apple, and let's call this Samsung and Motorola, and technology-wise, they have different. iPhone is based on their own technology, Apple's own and Samsung and other Motorola is based. Their technology is based on Google's Android. But either way, obviously, Apple wouldn't let other companies steal their or use their technology, right? So obviously, until they came up with their own technology, which is actually Google's Android technology, right? Apple iPhone was the only smartphone in the market, right? So they had a brief period of monopoly, and then the competitors enter the market, and now the competitors are growing at a very steady and fast rate because you might say, you can't compare Samsung with Apple. Apple's much better, blah blah blah. Some people, but honestly and personally, me to me, it's a debate between Pepsi and Coke. Some people might say, oh, give me Pepsi or death. Some it's just frivolous, right? Frivolous and trivial debate, right? Does it really matter? And people who are saying, iPhone is, there's no comparison. iPhone is far better. No, maybe it just satisfies you more, but objectively, I mean, iPhone may have better camera resolution or whatever, but as far as what a smartphone is, supposed to do, Galaxy is a wonderful phone, right? But in the early stage, maybe a difference in technology or a difference in resulting difference in quality maybe could have been discernible, but they are pretty much they deliver the same service, right? They do the same. They basically do the same thing. It's computer plus phone, right? Now, so in the second stage, which is called growth stage, the entire industry is almost growing at a by leaps and bounds, right? Now the competitors would be offering the product at a cheaper price, so there will be more sale of competitors' products, and the innovator's product generally reaches its peak, right? At this point, when the competitor reaches this peak, right, that means growth rate is zero, isn't it right? That makes sense. When it plateaus, right, that means it's no longer growing. Growth rate is zero, right? That's when it hits the apex or the plateau. It plateaus out, and then, but the innovator generally goes out in stage two. And growth means growth for the industry, right? Growth for the industry, not for just one company, right? And then in stage three, which is the maturity stage, right? Innovator generally goes into decline, and but the entire industry is in mass production stage, and then in stage four, it's in decline. Now, maturity means when it is mature, when the market is mature, right? The market that means there's no room for growth. So there's no room for growth. So the sales revenue hits the plateau, and the slope is zero because slope represents the rate of growth. But this is not necessarily always the case, because if it is a smartphone industry, right? As far as the smartphone industry is concerned, iPhone is still not here. I mean, iPhone may have hit somewhere around here, but it's not. It is still not in decline. Also, there are many examples of the industry not going into decline at all. Products may go into decline, but the industry doesn't. For example, one good example, the VCR, or video recorder and video player. Now, back in 1980s, there were two types of video systems, video player systems, VHS and Betamax. And actually, VHS system won out. Betamax went into decline. But even VHS system went into a decline by late 1990s because I mean by mid 1990s. Why? Because there's nobody was there was already a new product called DVD. So instead of cassette tapes, right? The contents were on DVD, so the DVD players took over. Just like cassette record players, cassette record players were replaced by Sony Walkman, and the Walkman, which was playing small cassette tapes, was replaced by CD-ROM Walkman, right? Walkman that was playing CD, and then by 1990s, video cassettes, VCR players are all gone. Products are phased out, but companies were still going because the industry simply replaced that VCR with DVD players. So products may go into decline, but the industries may not go into decline. Another example I would like to use is the bicycles. We're almost out of time, so I'm not going to go into the bicycle example. But what I'm trying to say here is, so here at least we can identify 4 different growth rates, growth phases. First, the growth phase that are exhibiting exponential growth, right? And then steady, and after that slower growth, right? Slower growth, and then zero growth. And then when it's in decline, what does the growth rate is negative, right? Now, of course, as an investor, nobody will be interested in the negative growth. Any company that is in negative growth or in the zero growth, right? As a rational investor, you will be interested only in the fast growth phase, right? They're all positive growth, and this is high growth, fast high growth, and relatively slower and lower growth rate, right? And as an investor, so the phase that are growth phases that are of interest to you are these 2 growth rates phases, fast growth phase and slower growth, slower and steady growth phase. Okay. Now, as for the exponential growth, I'm going to have to use a let's see, let me use whiteboard, right? So I'm going to switch to whiteboard. So how's can you all see this whiteboard? Okay, let me use the pencil. So when we say growth, actually there are 3 types of growth. First of all, this is growth clearly, right? But also, growth can take this pattern, right? So what is the difference between the 2? In this pattern, let's call it A, and let's call this B. In growth pattern A, the growth, what you can see is the growth rate is constant, right? Makes sense? In other words, if you take the slope, and what is the slope? Slope is the change in rise over change in run, right? And since this is a straight line, the slope is the basically slope represents the growth, and the slope is uniform or steady, right? It's just the same slope through and through. So that means it's growing at a constant rate. And of course, in reality, nothing is like that. I've been telling you, you can smooth it out like that, but in reality, it would be, right? There would be a lot of uneven fluctuations, right? Makes sense? There will be a lot of uneven fluctuations, but when smoothed out, it will look like that. Now, so this is constant growth, right? This is A is constant growth or steady, constant or steady. I'm not going to write anymore because this is not writing, this is growing. But what is B? It's called exponential growth. Because in exponential function, right? It first starts slow, and it grows at a very slow rate. Then you see, as time goes on, the growth rate is accelerating, right? It's growing at a faster rate, right? As time goes on, it grows at a more steeper and faster rate. That's why it's called exponential growth or exponential or exploding. That's really an explosive growth, is that right? Because the growth is accelerating. As time goes on, so this is the timeline. As the time goes on, right? Whatever this is, and this is the growth rate. the vertical axis is the growth rate, right? Explosive, right? When people say, pointing at, this straight line, if they say, oh, we are having explosive growth, that or exponential growth, that means he doesn't know. This person doesn't know what he's talking about. He doesn't know, right? If he knows any math, he cannot say this is, growing at an exponential or exploding. Only this is, exponential pattern of growth or explosive pattern of growth. Now, there's a third pattern, which is like this, right? Let's call this C. Growth pattern C. This is called decay, right? Why is it called decay? Well, the growth rate is decaying. Early on, it's, growing at a very steep or fast rate. As time goes on, the rate is slowing down. At a certain point, it plateaus out. That's called decaying pattern, right? So there are, three patterns of, growth, and being able to tell the difference, that means you know what you're talking about, right? If you're, all right. So that's it for.
Okay, so that was, video part 4B. So let's go into part 5. I hope this is a 1-hour video, maybe. Let's see. And I guess the best we can do today is part 5. It's 1 hour. Let's go for this.
We've been talking about the stock valuation models for the last couple of sessions, and what we are going to talk about is the product life cycle, the variable growth model, and which is, basically reflecting the product life cycle theory. So let's go into an example, and we discussed the background of the variable growth model in the last class. So let's move on to the example. So let's take a look at this. Most recent annual dividend payment to Warren Industries, a rapidly growing boat manufacturer, was $1.50 per share. So you need to parse the parse is the computer computer science term or computer engineering term, where you actually break down, analyze, and break down. So we need to parse the narrative, because, as I said, lots of times, oftentimes narrative is there's a lot of fluff in the narrative, and you need to you should be able to crystallize it, the gist, right? Boil it down to the very gist, not just, so 2012 is the most recent year. That means, we are at the end of 2012. We're at the beginning of 2013. But for us, because we are more, end of 2012 is the same thing as the beginning of 2013. And let's to have received the 2012 dividend. Of course, dividend is quarterly, but we're assuming dividend is annual in this example. Now, you cannot receive 2012 dividend during 2012. It goes without saying. 2012 have to end, right? 2012 has to end to receive the dividend. So that means we're already past that point. And some, usually the dividends are paid in the middle of the following quarter, right? The dividend that is being paid is, always the dividend from the previous quarter. So just like that, we can assume that the annual dividend of 2012, which is the most recent dividend, which is time zero, dividend at time zero, and if we received it, then that means we are already at some point in early 2013. But that's not really the critical thing. I mean, that's basically what we need to have as given. Now, they paid $1.50, right? That's the most recent dividend, and it says the name of the company doesn't matter, right? Warren Industries. Boat manufacturer. Which industry it is in? It's less important at this point, right? But one thing you have to focus on is the fact that it is rapidly growing. Now, remember, if it is rapidly growing, there is a phase where it is growing at rapid, right? You see this, cursor moving. I hope you can see this cursor moving. There is, a fast growth phase, and then slower growth phase, right? So if it says, rapidly growing company, then that means, there will be, in the later there will be a slow or constant growth phase later. So the firm's financial manager expects that the dividends will increase at a 10% annual rate, G1. That wasn't G1 in the original verbiage. I put it there to distinguish between fast growth and slow. So dividends will grow at 10% annual rate over the next 3 years. So the next 3 years will be the fast growth phase. At the end of 3 years, the firm's mature product line, now they say it's mature. Mature means now the growth will now slow down, right? Mature product line is expected to result in a slowing of the dividend growth rate to 5% a year, G2, right? Second growth rate for the foreseeable future. For the foreseeable future is just another way of saying indefinitely, right? Now you say, oh, indefinite. Clearly, they mean the different thing. Indefinitely, that means forever. Foreseeable future. But what is foreseeable future? It seems like it's smaller time frame, short time frame than indefinite time frame. But as far as the forecasting is concerned, you don't have. I mean, foreseeable future means, as far as your forecasting ability goes, and then beyond the forecasting ability, anyway, that is, there's no way you can make forecasts beyond that time horizon. So indefinitely is a foreseeable future. Indefinitely, basically, mean practically the same thing. Okay, because beyond indefinite future means, indefinitely within our forecasting ability. Now, so what does this tell us to do? Well, I'll get to that. We need one more thing. A firm's required return is 15%. Required return is the discount rate, and for now it is given. We take it as given, but in reality, nothing is given. You have to figure it out from the data, given data, right? So, well, we'll take it as given. So they have, okay, in the slide they it's done this way, but I will. I did it in Excel, and I will show you. I did it in Excel like this, so I will show you. Okay. So let's go to Excel first. I have to stop sharing, and then. So let's go to. So here's what I did for that given example. So let me blow it up a little. So it's a variable growth model. It's actually a two-step model. Okay, two-step. Why? Okay. Good. First, so the most current is 2012, and most current dividend is $1.50, right? It's time 0, right? And dividend growth rate for the last 3 years is 10%. So what do? I can forecast dividend in time 1, time 2, time 3. Time 1 is of course 2013. How did I do that? Of course, making just 1 year forecast by 1 year compounding, right? So what I did was C27 is this, right? I lock it because I'm going to drag it down, and then D27 is the growth rate. I lock it, right? So I can drag it down, and then raise to the times digit, right? And then I drag it down. It generates, future, for 3 years, next 3 years, the dividends. And then valuation is always what? The valuation is always, the present value. So we will need the present values of these. So present value is basically what? You will need to discount it, right? So the discount rate is 15%. So I will discount it by, so I lock, discount rate and 8, by 1. You might say, oh, why do we do that? 1, it doesn't do anything. It doesn't matter. I mean, it may be 1 for this one, but it will come in handy when I down, right? So there you go. And then I drag it down. Okay. And then I do the same thing, as I drag it down, right? So I have the present values of all these future dividends, and I sum, right? The present value of all of those dividends are like this. But that's not the only thing. That's the present value of all those dividends during the fast growth phase. But beyond that, beyond the fast growth phase, when the growth rate settles to 5%, what do? I mean, there will be dividends growing at 5%, and there will the future value of the But first of all, let's think about it. Beyond 2015, that means from 2016 and indefinitely, the dividend grows at a constant rate. When look, this is the Q. Constant rate means what? Oh, that means golden growth model or constant growth model. Make sense? In other words, beyond 2015, the valuation of we will need to find the valuation of this stock, right? As of the end of 2015, right? Which 2000. So for stock valuation, to apply the Gordon growth model here, right? The time zero will have to the time zero will be 2000, end of 2010, right? For the second period, for the slow growth period, right? Constant growth period. So we know the growth rate, we know the required return. We can calculate the stock price as of the end of 2015, right? That's why I put it like this: price of the stock as of end of 2015. So using Gordon growth model, and then because we know the growth rate of the second phase, which is 2016 and after. I mean 2000 past after 2015, and we can make a forecast 2016 dividend, which is simply this times 1 plus this, right? 2016 dividend will be like that. There you go. Then using Gordon to dividend at time t plus 1, which is this, over r minus g. Okay, and we got a price as of the end of 2015. But again, 2015 is not where we are. We are at what point? We are at the end of this time zero is where we are, isn't it right? We're at the end of 2015 or slightly past that. So then this is like end of 2015 value. So what do we need to do? We will need to discount it back to 2012, which is 3 years back. So what do? We discount it, right, by of course r raised to 3 years back. Right, makes sense. Then we get the price of this stock as of the value of 2000 value of this stock as at the end of 2012 is this 13.78. But at the end of 2015, it's not only that. I mean, this is only the present. This is only the present value of all the cash flows beyond 2015. What about the cash flows between now and end of 2015? Well, we already got that, right? Present value of all those is 412, and present value of this is 1378. So the actually the stock price at the end of 2012 is the sum of these two. Make sense? So we got it. So 1790, that's to be exact, right? The book is rounded. The book is rounded numbers, so you get the the rounded values. So as let's see, 18. It gives you 1793, but exact one is 1790. Okay. Now, so this is the third model. Let me stop sharing the Excel file and go back to 4 models. This is the third model, variable growth. And what is the fourth model? Fourth model is called free cash flow model. Free cash flow. Now, what is free cash flow? First of all, we've been assuming dividend is the cash flow. In case of dividend is the cash flow in stock. But then think about it. So the stock valuation models are called, I told you, DDM, dividend discount model. But what if the dividend? Some companies, some companies don't pay dividends, right? Companies pay dividends, but they may skip the dividends for a number of years, right? And then resume the dividend again, dividend payout. But some companies don't pay dividends. So if this is the case, how do you value those companies? In other words, dividend discount model is useless, right? Dividend discount model breaks down when there is no dividend, right? And how do you model the companies that don't pay dividends? How do you right? How do you value the stocks of the companies that don't pay dividends? Again, then then we'll have to we'll need something that don't depend on dividends. And so the only other option, the best alternative, is free cash flow. And what is free cash flow then? Free cash flow sounds like a very liberal thing, liberally defined because the name is free. But free cash flow is not really liberally defined, but it's very rigorously defined. So let's define. Let's understand what free cash flow is first. Actually, free cash flow is defined verbally in so many ways. You know, they say cash generated beyond reinvestment needs, net cash flow less non-operating cash requirements. So what are those? It's not really. It's all very foggy, nebulous, right? That's why I don't like verbal definition, because day one I said, I don't, verbal definition is not infallible, right? It's there's always, it leaves, room for different personal interpretation. So if it is defined like that, it is useless. The best definition is always the mathematical definition, because there's no, it's indisputable, right? There's no room for any subjective interpretation. So mathematical definition of the free cash flow is like this. Free cash flow is equal to operating cash flow minus investment in operating capital. So then what is operating cash flow? Operating cash flow is defined as EBIT minus taxes plus depreciation. Okay. And investment in operating capital means, operating capital, comes in two parts, right? Look, your fixed assets or non-current assets, right? Those are the physical capital or physical assets, right? There will be change in physical capital, physical assets, right? Over time, you add more. I mean, first of all, the value of your physical assets would change, mainly because it will go down in value due to depreciation. I mean, it's inevitable because of the wear and tear of the equipment due to usage over time. The aging, of the physical assets have to bring down the value of valuation of the physical assets. Anyway, it's getting old, so with usage, it gets less and less productive because of wear and tear, right? And it will the management won't just watch it hands down, right? When the production capacity goes down, they won't just watch it hands down. They will replace the worn out portion of the capital, right? So they will try to maintain the original production capacity, or even more, even want to raise it to a higher level. If the economy is good, the demand will increase, so they will need to increase the production capacity, right? So there will be a change in fixed assets. And what's the other part of the other what's the other counterpart to fixed assets? It's working capital or current assets, right? Current assets will also is constantly in flux, right? So there will be a change in current assets, but net working capital. Current asset is called working capital. Net working capital is the basically the net. In other words, current assets minus current liabilities is called net working capital. Okay. So that is the investment in operating cash flow. Now, operating cash flow, that name, that word sounds kind of familiar. Why? What is operating income or operating profit, right? Okay. But isn't operating cash flow similar to operating profit or operating income? No, slightly different. Why not? Why is it not the same? First of all, this is the operating income, isn't it right? EBIT is another name for operating income. But then operating. So how is it different from operating cash flow? It is different. It is different by as much as this, minus taxes plus depreciation. So first of all, not all of the EBIT is cash flow to you. Why? Because taxes you can't touch. That's something you owe the government, so you can't touch it. It's not your and normally interest is also it belongs to the lenders or the creditors. So interest is usually not something you can dispose of. Something you can dispose at your own will. But there can be no interest payment. There can be no interest expense, right? Why? If you don't have any debt in your capital structure, right? There's no interest. Anyway, even if that's the case, interest is not untouchable, right? So only taxes are subtracted from it. But then why do you add depreciation there? I mean, isn't it already subtracted in the isn't it already subtracted from the balance sheet? Because depreciation is first shown in the balance sheet. Why? Because in the fixed assets, right? In the fixed assets section, you have plant and equipment, right? Land and building, right? Those are mainly your fixed assets. And last item is depreciation. Of course, depreciation is a minus, negative number in the balance sheet because it has to bring down. It has to bring down the value of the fixed assets. But then it's also appearing in the income statement as part of the operating expenses. But think about it. When it appears in the operating expenses, right? This is actually a phantom. Why? We had, when we went over the financial statements, we didn't have to talk about depreciation. But, we may have. It just can't trace back to when we did the income statement and balance sheet. But I told you that depreciation is something like this. Now, of course, it reflects the declining book value of the for business assets, right? For business assets, depreciation is totally optional. It's not really following. It follows artificial schedule, and it has nothing to do with the actual resale. So this way, a company bought a car. You pay $50,000 upfront. There are some you can pay for the car. You can pay cash, lump sum cash, right? And then you can finance it. I mean, of course, financing is more rational. Right, lump $50,000. So as a company, it's a business asset, right? So this will be, just like a plant and equipment, right? It will depreciate, and also, so you paid $50,000. Let's say you bought it on January 1st, so it's time zero, right? Time zero of the first year, right? January 1st. And since you paid 50K in lump sum cash, right? You will write it off as expense in the income statement, don't you? You will. Yes, you have to write it off as business expense. You'll write off 50,000 in year one. Normally, that's what you would think, right? But then think about it. IRS doesn't want you to do it this way. And I'm not going to go over the rationale behind it, but IRS want, because if you write off 50,000, that then means EBIT goes down by 50,000. If EBIT goes down by 50,000, that means EBT will go down by 50,000 as well. That means EBT is the tax base for the IRS. Now, that means what? As EBT goes down by 50K, then which is the taxable income, the tax will go down by 50%, by as much, right? It's not exactly 50,000, but if the tax rate is 40% of 50,000, it will go down by as much as that. So IRS doesn't want you to write it off in year one. Instead, they will want you to write it off spread over 5 years, for example, 5 years. So that means each year 10K, right? So think about it. In year one, you're writing off only although you actually in $50,000, you're writing off only 10,000 in the first year. And year two, from year 2 through year 5, you write off $10,000 every year, but you didn't incur that expense in year 2 through year 5. You never incurred them in those years. So from year 2 through year 5, actually, these are expenses that never happened. That's why it's called, also non-cash layout. There was no actual cash payment, but you write off 10K as if you actually spent 10K. Whereas then what does that create? What does that do? It creates a phantom expense, right? A hollow expense that really didn't exist. That just contributes to reducing your EBIT, which will reduce your EBT by 10K from year 2 through year 4, which will reduce your taxes by as much, right? So in other words, this is like from year 2 through year 4, the depreciation is like giving you a cash back, because it's like preserving $10,000, right, from taxable income, saving it from taxes, because as much as $10,000 in year 2, 3, year 4 was not spent, but it was showing as if it was spent. So it's like preserving $10,000 each year. So, right? So that adds to the cash flow. Makes sense? So that's why adding back. Now then, think about it. This is the cash flow generated from operating activity, right? And then if there is any need for increase or decrease, increase in the changes, increase or decrease, changes in operating capital, that should come out of where? It should come from your operating cash flow. That's what is meant by net cash flow less non-operating cash requirements, right? Net cash flow less or cash generated beyond reinvestment needs. These are reinvestment needs, isn't that right? Changing gross fixed asset means if you expand your production capacity, right? More plant and equipment, right? There's additional reinvestment, right? Additional investment. Beyond that, right? Cash generated. So this is literally now free to the free for the owners, free to the owners to spend as they please, right? That's why it's called free cash flow. Okay, but free cash flow is really rigorously defined. Okay, so with that in mind, so we understand now what free cash flow is, and since the company doesn't pay dividend, the only the cash flow we need to consider for such a company is free cash flow. Now, and then think about it. Free cash flows are all basically future cash flows, right? So we have to discount it back to present. All these free cash flows, going all the way to infinity. The stream of future cash flows, right? We have to discount it. And if we discount it, that result is that's what? That's the value of the company. Think about it. What is the value of the company? I can tell you the value of the company is generally the book value of the company, book value, right? But the value of the company is what? Total asset value, isn't that right? Total asset, because total assets is equity plus total debt. And equity plus total debt is defines the size of the company, because total assets come from equity and debt, and with the total, with the equity and debt, you acquire assets like fixed assets, plant and equipment, land and building, and the current assets, right? So, but that is based on the book value. And I told you, book value is always based on the past data, right? There's no way you can. Book value is always, no matter how updated, up to date it may be, book value is always based on the most recent one. Most recent one is always past, because we barely have first quarter data coming in, because we are in May. So actually April. In April we got the first quarter data in. So we are already in May, and the first quarter is already 1 month behind. So the first quarter data is already passed, but that's the most recent data, right? So, but then value of the company based on the book data is, as I said, it's not the most, it's not the current value, right? So current value, you must use, what is the rational intrinsic value? It's always discounting the future cash flow, right? So the value of the company is actually its present value of all its earnings power, future cash flow, right? So this is the intrinsic value of the company, or the rational value of the company, right? Or fair value of the company, not the book value, right? Now I've been telling you, there are three valuations, three types of values. One is book value, the other one is intrinsic value, the other one is market value. And I can tell you, market value is, in the short run, irrational. Book value is past. Now, if the market is in equilibrium, the market value is equal to the intrinsic value. Right? Makes sense? So that's that's what we need. The intrinsic value. But if you have intrinsic value, then that is not the stock. Why? Stock is basically equity, right? And you understand the just like total assets. This is basically the workings of the value, current value of the company as the result of the workings of the total assets. But we understand the total assets consist of equity and debt. And equity breaks down into a common stock and preferred stock. So the idea is value of the company is a sum of the value of the common stock, value of the preferred stock, and value of the debt. So let me use the whiteboard. Let me go back and.
So this V subscript C, value of the company, is close to the concept of enterprise value. Enterprise value. Okay.
Okay. If I go to the whiteboard, right? Oops, what happened? Right? Is equal to the value of the common stock. This value of the preferred stock. And the value of the debt, right? So this is like, the balance sheet. This is what? equity, and this is debt, right? This is like total assets. But once again, total assets is simply based on the past data, actual capital raised. But this is based on earnings power in the future, right? Future cash flow. So then we're not solving for this. We are actually we are interested in this. So value of the common stock is then value of the common stock is then value of the company minus value of the preferred stock and the value of the debt, right? Makes sense. So we can isolate value of the common stock, but then this is the aggregate value. In other words, value of, if there are like 1 million shares outstanding, right? 1 million shares of common stock outstanding, and each share is $10, right? The total amount of the equity, total value of equity is 10 million. What does that mean? What does that tell you about the price per share? Which we know price per share is $10, because if the total equity is 10 million and around 1 million shares outstanding, simply divide by 1 million, right? $10, right? So price per share. So if we call that S0, right? Now, of course, book value is like book value per share. But the only reason I'm not calling it book value per share is this is not past data. This is not based on the past data, right? This is based on the future cash flow. So yeah, then all you need to do is simply divide value of the common stock by number of shares outstanding. Okay, number of shares. All right, so now let me get back to we divide by. But then the next question is, what do we use as the discount rate? That's the critical question. Why? What is the discount rate that we need to use? Oh, isn't that the required return that's normally given? No. First of all, required return won't be given. Normally. You'll have to figure out. This is just a very basic example, so very rudimentary example. So required return was given, but in real, it's not going to be given. And two, this free cash flow is like the fruit of the tree. Now think about it. The tree is the company, right? And free cash flow is the fruit borne by these trees. And think about it. The tree consists of common stock, preferred stock, and bond, the debt, right? The tree consists of these three components, right? Tree is the the tree bear fruits, right? The fruit is the result of the workings of the common stock, preferred stock, and debt. Make sense? So then, if it is only common stock that contributed to bearing these fruits, then you discount it by the appropriate discount rate, the required return for the stock, right? And if it was the fruit is the result of only the workings of only the bond, then debt, you discount it with the cost of debt, right? The yield, right? But then you understand this is the fruit is the result of the combination of the workings of equity and debt. And what do you use as the discount rate? That's where the weighted average comes in, capital structure comes in. Think about it. If the capital structure is 60% equity, 40% debt, we can reasonably assume that 60%, the fruit is the result, the harvest of the fruit is the result of the contribution, 60% contribution, the contribution of these bond stocks are exactly in the proportion of the capital structure, right? So the contribution is to this fruit is from 60% from equity and 40% from debt. Right, makes sense. And if the equity once again breaks down into common stock and preferred stock, and also the proportion of common stock and preferred stock, usually, so anyway, so let me. So that's called so in other words, what you need to do is the capital structure. In other words, equity ratio, right? 60% times required return plus the debt ratio, 40% times the cost of debt, right? And
okay, so the important concept here is the weighted average cost of capital, right? So we understand the concept of weighted average. So basically, it is weighted by their own capital component. right? Each discount rate, cost of equity, and cost of debt are weighted by their own capital component, right? So that's um, we need to, of course, continue with this tomorrow because we're already out of time. So we'll pick it up from here tomorrow. Okay. All righty. So that's it for today.
Thank you,
Um,
sir.
all right. You're welcome.
Thank
You're
you. Have
welcome.
a good evening, Professor. See you tomorrow.
All righty. Take care, everyone. And good night, Jasmine. We'll see you tomorrow. Okay. So stop recording.